Okay, in this video I'm going to show you how the sine, cos and tan graphs are derived from the unit circle. I will also give you a GeoGebra link so you can have a play around with an animated version of this, which we would normally do in class, but obviously we can't at the moment. So there's my point P. We'll start with sine theta. So sine theta is equal to y on this unit circle. So the value of sine theta is equal to the value of the y coordinate. So if you imagine this point P, and we're going to swing it around the unit circle. So when theta is 0 degrees, the coordinates of P are 1, 0. So the y coordinate is 0. So if I want to draw the graph of y equals sine theta, the y coordinate is 0 when theta is 0. Coming up to here, where theta is 90 degrees, the coordinates of P are 0, 1. So at 90 degrees, the y coordinate equals 1. Back round to 180 degrees. And now the y coordinate is equal to 0. At 270, the y coordinate is minus 1. And then we're back to 360, where the y coordinate is 0. Round another 90, the y coordinate is 1. And similarly, if you go in a negative direction, so minus 90 degrees, the y coordinate is minus 1, and then to 0, and then to 1. And so joining all these up with a smooth curve gives us the sine curve. Similarly, the value of cos theta is equal to the x coordinate. So to sketch y equals cos theta, we're looking at the value of the x coordinate. So when theta is 0, the x coordinate has a value of 1. When theta is 90, the x coordinate has a value of 0. Then minus 1 at 180, 0 at 270, and then the x coordinate is 1 at 360, 450, the x coordinate is 0, and then I can go back round the other way. So at minus 90, the x coordinate is 0, and then at minus 180, the x coordinate is minus 1. And so cos curve is looking like so. Sine and cos have exactly the same shape, so they are the same shaped curves, which is how they look. Tan theta, slightly more difficult. We're going to use tan theta as sine theta over cos theta. I'll scrub off the unit circle because I don't think we're going to need it for this. So tan theta equals sine theta over cos theta. Don't worry if you find this one more difficult. I'll try and show you what's happening with it. Right, so when cos theta is equal to 0, tan theta is undefined because we can't divide by 0. And that gives you a vertical asymptote. So we've mentioned that a little bit in class. So where cos theta is 0, so cos theta is 0 at minus 90, and it's 0 at 90, and again at 270. So every 180 degrees on the tan curve, you get a vertical asymptote. So there'll be another one here at minus 270. And then when sine theta is 0, tan theta is 0, because 0 divided by any non-zero value will give you 0. So the tan curve, sine theta is 0 at 0, at minus 180, and at 180. So it's passing through those points there. As we approach 90 degrees, we need to look at what's happening with this asymptote. As we approach 90 degrees, sine theta is approaching 1 and cos theta is approaching 0 from above. So we're looking at something like 0.9999 divided by 0.0000, just lots of zeros and a 1. That's going to give you an infinitely big number. So we're approaching positive infinity here. As you go to minus 90, then sine theta is approaching minus 1. So I can put a minus on there. And as I approach minus 90 from this direction, cos theta is approaching 0, but from a positive value. So it's going to still look something like this. So that's going to give me an infinitely big negative number, because I've got negative on top, positive underneath. And tan comes up through like this. And then you can repeat that process, looking at what happens as you approach minus 90. So sine will be minus 1, cos will be close to 0, but coming from below. So that's going to give you a positive there. So it's all about taking limits for tan. You need to know the shape. You don't need to know how to derive it. So sketching tan, you've got these asymptotes every 180 degrees, and then the tan shape repeating up, and these are all the same shape. So sine repeats every 360 degrees, cos repeats every 360 degrees, and tan repeats every 180 degrees. You need to know the graphs of all those, but we'll be using them quite a lot, so you will remember them. So we'll start looking at using them and finding different values on the next video. Hope that made sense, but I will give you a link to a GeoGebra app as well, which you can play around with. Okay.